This is 2.1 Pre-Calculus, Day 1, Part 2. We've just focused on what is a quadratic equation and how to graph in vertex form applying the transformations. We're going to move on to the next form, which is what we call standard form. This should be a nice review from you for Algebra 2. Here are some steps to help guide you through graphing if they give you an equation in standard form. Remember from Algebra 2, to find the axis of symmetry, you use the formula x equals negative b over 2a. And where you get the b and the a is from the equation. So here is my formula. To find the vertex, remember the axis of symmetry runs through the vertex point of a parabola. So my x value is the same as the x value for the axis of symmetry. But then to find the y value, I have to evaluate the function, so the orange function for negative b over 2a. Part 3, to find the y-intercept. This is the easiest part, if you remember from Algebra 2. There is your y-intercept. When it's in standard form, you can quickly look at the c value, the constant, and that's your y-intercept. The last thing is identify if the graph opens up or down. If a graph opens up, it's going to have a positive a. The graph will open down if it has a negative a. We'll give you a little bit of time to take that in, and then we have one example on the next slide using the standard form. All right, here's our example. H of x equals 2x squared plus 4x minus 2. We want to look at the equation. The equation is in standard form. It has the x squared, it has the x, it has the constant. So let's identify what is the value of a, b, and c. Well, the a is right here. The b is the coefficient in front of the x term, and then the c is the constant. So next, let's go ahead and find the axis of symmetry. To find the equation for that axis of symmetry, from the previous slide, we gave you this formula. X equals negative b over 2a. So we're going to substitute in the b and the a in. So the b is 4. The a is 2. Now let's just reduce that. Negative 4 over 4 is negative 1. So the axis of symmetry is x equals negative 1. If I come over here and graph it on my graph, which you don't have to do quite yet, there is my axis of symmetry at x equals negative 1. Now to find the vertex is going to run through that axis of symmetry. So my x value for my vertex is also negative 1. But I have to find out what's the y value. So I'm going to substitute negative 1 into the function. I'm going to just drop the h of x notation and just replace it with the letter y. So now the rest is 2x squared plus 4x minus 2. Now let's evaluate this equation, this function, when x equals negative 1. So replace each x value with negative 1. And now we're going to just use our orders of operations and reduce that down. Negative 1 times negative 1 is 1. And now let's multiply. 2 times 1 is 2. 4 times negative 1 is negative 4. And then we will simplify. 2 minus 4 is negative 2. Negative 2 minus 2 is negative 4. That is your y value for your vertex. So now I have my ordered pair of my vertex. So if I graph that, I'm going to go left negative 4 and then down 4. The y-intercept, very quick. The y-intercept is the c of the equation in standard form. That's over 0 down negative 2. Then to figure out if the graph opens up or down, I have a positive a. The a is 2, a positive. So I know my graph must open up. I can also graph that y-intercept over 0, negative 2. Remember symmetry. I should have another point right here. And now I can graph that parabola. The parabola opens up. And that's just a quick sketch. I haven't identified the x-intercepts. We'll leave that to the next slide. I'm going to stop there. It's about 6 minutes.